Good morning, sirs and madams. My name is Shasham Kumar Reddy from Annamacharya University, Andhra Pradesh. I am from related to EC group. I am very glad to meet this internship in the online programs, and I have enhanced my skills on the embedded IoT, and I have completed the many project from the online classes and recorded sections in the LMS. I have learned many new skills and more information about the IoT and embedded. I am very glad to this internship opportunity. I have learned many skills. I have learned C programming, C++ language, introduction to IoT, introduction to embedded systems, introduction to project and its requirements, programming LED, CLCD, ADC, temperature sensor, PWM, serial tank, controlling LED using LDR, blink app configuration. It controls devices like heater, cooler, serial tank, through blink, cloud server, and display notifications. Coming to C programming, C language is powerful, efficient, flexible, deep we can explore our system. C important characteristics are it is a general purpose language even though it is applied and used effectively in various specific domains. It is a free formatted language. Efficiency and portability are the important considerations. Library facilities play an important role. C language is used in system software development, embedded software development, OS kernel development, firmware, middleware, and driver development, file system development, and many more. C language consists of data types, conditional construct, operators, arrays, pointers, recursion constant qualifiers, strings, storage classes, preprocessors, and UDT. C keywords categories, data types, modifiers, qualifiers, loops, jump, decision, storage class, derived, user-defined, and others. These are the keywords that we are used while programming in C. Typical C code contains documentation, preprocessor statements, global declaration, the main code. In main code, local declaration, program statements, function calls, one or many functions, the function void. This is the example of C language program for Hello World. C++ language. C++ is a statically typed, combined, general-purpose, case-sensitive programming language that supports procedural, object-oriented, and generic programming. It adds many features to the C language and is perhaps best thought of as a superset of C. C++ language consists of class, object, access specifiers, modifiers, constructors, and destructors. C versus C++ language. C++ is mainly object-oriented programming language, while C is procedural-oriented programming language. In C, program is divided into small chunks based on the functions. In C++, program is divided into objects depending on the problem. Each function contains different data in C. Each object controls its own data in C++. follows a systematic approach to solve the problem in C, focuses on security of data irrespective of the algorithm in C++. In C, no easy way for data hiding. In C++, data hiding is possible in whole. When compared to C++, C is a subset of C++. C++ is a superset of C. C++ can run most of the C code, while C cannot run C++ code. C supports procedural programming paralleling for code development. C++ supports both procedural and object-oriented programming paralleling. Therefore, C++ is also called a hybrid language. C does not have namespace feature. C++ uses namespace which avoid name collisions. C does not allow functions to be defined inside structures. In C++, function can be used inside the structure. C has no support for virtual and friend functions. C++ supports virtual and friend functions. These are the comparison between C and C++ languages. Applications of C++. If you need high performance and precise control over memory and other hardware resources, then C++ would be nice choice. Few applications of C++ are video games, high performance financial application, graphical application and simulation, productivity office tool, embedded and real-time software, audio and video processing. Coming to introduction to IoT, Internet of Things is abbreviated as IoT. The definition of IoT is the network of physical objects that contain embedded technologies to communicate and interact with their internet states and or the external environment. Unique objects are connected to internet. Devices are connected, not the people. It is bidirectional communication. It is large, complex data flows. It is new types of insight. Applications of IoT. From home to at workplace, we are using many applications to IoT. Like we use IoT in alarm clock, refrigerator, automobile, Vivo IP phone, computer, printer, media player, microwave, coffee maker, smart scale, oven, cell phone, vending, security, televisions to control these appliances. Internet of Things. It is the reference architecture of IoT. Like device connectivity, data processing, and analytics presentation. Coming to introduction to embedded system, we have many definitions for embedded system. One of the definition is any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Embedded system categories are standalone, real-time, networked, and mobile. Examples. These are the examples of embedded system. They are microwave oven, washing machine, television, CC camera, refrigerators, car, robotics, aeroplane, MRI scannings, CD drives, Wi-Fi routers, and missiles, mobile phones, and etc. Components. These are the components of embedded system. Basically, embedded system consists of input, output, microprocessor or microcontroller, or we can say it as system on chip. On other peripherals like software, digital to analog converters, analog to digital converters, diagnostic ports, actuators, sensors, actuatory system, human interface, memories, FPGA or AI IC. So they like which see in the slide. Coming to introduction to project or and its requirements the project title is IoT-based home automation solutions. The home automation is able to control the light, temperature of the home, inflow and outflow of water in that water tank. It is simulated on the PixSim simulator, Blink IoT mobile application used to control the devices. This project requirements are the Arduino IDE with Simlac simulator, null emulator, Blink IoT, mobile application. It is the hardware, the Arduino Uno hardware board. It has pin configuration. Arduino IDE software tool. In this, we can write the program and we compile it and burn it on the PixSimLab simulator. Here it is a PixSimLab simulator. The code is dumped into this simulator and output is seen by some of the spare parts connected to it. Arduino requirements are LED temperature system ADC, LDR light dependent resistor, serial tank, it uses serial communication, Ethernet chain, Blink IoT app, LEDs, light emitting diodes. Simplest device used in most on the embedded applications as feedback. Works just like diodes, low energy consumption, longer life, smaller size, fast switching, make it usable in wide application fields like home lighting, remote controls, surveillance. CLCD character liquid crystal display. Most commonly used display ASCII characters. Some customizations in symbol possible. Communication modes are in 8-bit mode and 4-bit mode. Analog input. Analog to digital converter. It's pulse width modulation. Very important peripheral in embedded systems for real-time activities. The controller understands only digital signals, so and real-time linear signals have to be converted into digital form. It is multiplexed with general purpose input and output. Comes with a different architecture. XOR is the most commonly used. Here, SAR stands for Successive Approximation Register. LDR, Light Dependent Resistor, reads the earlier sensor value based on the reading from LDR, vary the brightness of LED, which resembles controlling garden lights based on the availability of sunlight. So in the daytime, the light will get off by this sensor, and at the night time, in the absence of sunlight, the light blow by sensing the LDR using LDR. So earlier senses and new information to the Arduino Uno, and it turns off and on the lights. Temperature control system. The temperature control system consists of a heater resistor and a LM35 temperature sensor and a cooler, which resembles the temperature control system at home. Raise the temperature from the temperature sensor LM35 and display it on that CLCD. Control the temperature of the system by turning on off the heater and cooler through the Blink IoT mobile app. Here, CLC temperature system gives the information to Arduino Uno and it goes to the Blink IoT and the notification is reached to the CLCD through Arduino Uno and CLCD displays the notification and in the Blink IoT app also we can see notifications. Serial tank. It is for the serial communications. It reads the volume of water in the tank through serial communication and displays it on the CLCD. Controls the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Displays the volume of water in the tank on the CLCD. Null emulator is required for the serial communication. It provides common COM2 pairs. By this COM pairs, we can communicate to serial tank for the Arduino Uno. Blink IoT app. Blink is a full site of software required to prototype, deploy, and remotely manage connected electronic devices at any scale, from personal IoT projects to millions of commercial connected projects. With Blink IoT, anyone can connect their hardware to the cloud and build a no-core iOS, Android, and Blue web applications to analyze real-time and historical data coming from devices, controls them remotely from anywhere in the world, receive important notifications, and much more. Blink was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many more cool things. It creates widgets on mobile Blink application. Button widgets to control heater, cooler, inlet valve, outlet valve. Gauge, gauge widgets to display temperature and volume of your water in the tank on the mobile application. Terminal widgets to display the notifications whenever threshold is crossed like temperature is more than 35 degrees. Turn off the heater. Water level is full. Water inflow is visible. IoT-based home automation solutions. It is those. Here we can see the home appliances like lighting, garden lights, like those are home appliances are controlled using Pixel Lab device. It is connected to Blink app that is in our installed in our mobiles. So we can control with our mobile app Blink our home appliances through the cloud server. This is a project code. Now we will see oral presentations. This is my project code, home automation Blink control. Here we include many files. other files like layer.cpt. It is a C++ language file. It is layer.h. It is a header file. It is main.h file. It is serial.cpp file. Serial.h file. Temperature sensor.cpp file. Temperature system.h file. By using this LDR, serial tank, temperature system, and main.h, and home automation blink control files, we are going to implement the project. Now I am saving the project code. It is done saving, then go to compilation, compile it, done compilation successfully. Now we go to sketch and export compile library. Then we have to go to Pixim Lab Simulator. Here in the file, we have to load hex file. Values. In this home automation blend control file, open it. It is loaded and go to spare parts to serial tank. Now more I am controlling the light LED light to the LDI light dependent resistor. As we are decreasing, then the light goes off. As we are increasing the optimum and their value, the light on. Then, as we are on the cooler, here we are seeing that cooler is running. Now we are off. Then fan stopper off. Off heater is on. Fan. We are displaying heater on the COCD, and it is get off when reached 35 degrees, and we are viewing the temperature is about 35 degrees Celsius, turning off the heater. Now we are in that blue. Outlet valve is on and tank is started flowing water out tray. Now we are seeing the tank gets filled. And inlet valve is on. Automatically, after filling the tank, inlet valve get off, and we are view notifications in the mobile app that water level is less than 2000, water inflow is enabled. Water level is full, water inflow is disabled. Thus, we see the notifications in the Blink IoT app. Here,